Hello, listeners. This is Mike, your host. If you are enjoying these archive episodes, please consider supporting the podcast by going to the homepage, spacerockethistory.com, and clicking on the orange donate button or the Patreon link. Hopefully, with your support, I can continue to release these archive episodes. Thanks.
We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard.
Godspeed, John Glenn.
Roger, 0G, and I feel fine.
I feel out. Okay, I'm out.
How does it feel for the United States to be the new record holder?
At last, huh?
When that baby lights, there's no doubt about it.
Liftoff. We have a liftoff. 32 minutes past the hour. Liftoff on Apollo 11.
Houston, Tranquility Base here. The Eagle has landed.
That's one small step for man, one giant leap for mankind.
Hello and welcome. This is Michael Annis, and you're listening to episode 180 of the Space Rocket History Podcast. And now, Apollo 9, Lunar Module Maneuvers. To the rest of the world, the 10-day Earth orbit mission of Apollo 9 must have seemed decidedly mundane, coming as it did on the heels of the first flight around the moon. But few astronauts would have been surprised to learn that Jim McDivitt had turned down the circumlunar mission to stick with this one. They wouldn't have said so publicly, but many saw Apollo 8 as little more than a ride, no real flying involved. But Apollo 9 was a test pilot's feast. In truth, it was far more difficult, more ambitious, and in some ways more dangerous than Apollo 8. For the engineers, the demands of getting two manned spacecraft ready for flight were headache enough. The simulators kept breaking down. There were days during training when McDivitt would go home and tell his wife it couldn't be done. It would never all come together in time. Miraculously, it did, and McDivitt's crew was launched on March 3rd. They figured that if they accomplished half of what was in the flight plan, they'd call the mission a success. Those were the words of the great space author Andrew Chaikin. We ended last episode, number 179, just as Apollo 9 reached orbit. Before we resume the mission, I have a clip on the history of the lunar module to put in perspective how NASA reached the Apollo 9 mission on March 3rd, 1969.
Jim McDivitt was not always so confident. He and his fellow astronauts have watched with understandable concern as engineers tinkered with the LEM over the years, making changes to improve it and changing the improvements. Tracing the LEM from its first concept through to its present incarnation gives some idea of how radical those changes have been. Part of the problem was they had to start to work before they really knew what they needed to land on the moon. Weight has been a crucial problem all along. 1/10 of a pound saved was cause for cheers. Metal was shaved wherever possible, and in some cases shaved too closely. A fuel tank pared down to save weight finally burst and had to be redesigned again. The first LEM got all the way to the launch site only to be shipped back to the factory because of fuel line leaks. And just last month, 9 fittings on the latest LEM were replaced because of a kind of metal fatigue. The Apollo fire caused the same kind of retesting and rethinking of the LEM as it did of the main spacecraft. The interior was rechecked and then more delay as flammable material was removed, wiring redone, and fire extinguishers installed. The astronauts, too, added to the wait and the delay by insisting they wanted radar on board so they could monitor the rendezvous. The engineers got even by taking away their couches and forcing them to stand, but the astronauts didn't really mind because the trip is short after all, and besides, now they can get closer to see out the rendezvous window placed awkwardly over their heads. But the most serious problem has been with the engines. The ascent engine, in its ground checkout, developed trouble something like a knock in your car's engine. The repair bill was slightly more, though, $5 million. The descent engine has had its problems, too. It also ran rough, and then 2 of them blew up during ground tests. Finally, months behind schedule, everything was put together, and the first and only LEM to fly so far lifted off its launch pad at Cape Kennedy. There were no men aboard this one. Neither engine worked as planned, but NASA decided the engines were not at fault, blamed electronics, and called the test a success. Still, a year later, a manned LEM was not ready, and so Apollo 8 carried thousands of pounds of water and not a LEM to the moon. It seemed only fitting somehow that if there was to be a LEM simulator to teach astronauts how to fly the LEM, it should have trouble too, and it did. Or rather, they did. 2 of them crashed. No one was hurt, but officials decided that training was more dangerous than the mission and grounded the trainer. Despite its hard luck history, George Skurla, the man responsible for assembling the LEM at Cape Kennedy, is still confident.
We've had our problems, but I think they're all developmental problems, and the spacecraft is a very sophisticated spacecraft. And we had problems with LEM 1 that we solved, and the vehicle was launched and flew successfully. And we had some problems with LEM 3, and we've solved those, and we fully expect that that vehicle will fly and fly well.
And one of the 2 men who is betting his life at will also has reviewed the problems.
Now, when we started out, we, meaning the Grumman Company and NASA, to learn how to build a spacecraft like this, there were a lot of problems. We had super lightweight wiring and super lightweight everything. And there were some things that were just too super lightweight. And we made those a little heavier. But we went through the development, and we were assigned to LEM 2, saw it go through its growing pains. Then we got LEM 3, and its saw its growing pains. But we've reached a point now where I have great confidence in the spacecraft. It's nothing wrong with it. It showed itself in tests to be very reliable.
Despite the public confidence of the men who build and will fly the LEM, there will be a collective sigh of relief when this mission is over. For all the publicity of the hazards of Apollo 8's flight to the moon, it is this flight of Apollo 9 that has concerned insiders most, and will really determine whether we'll be successful in our commitment to land a man on the moon before the end of the year.
The first maneuver for Apollo 9 will be the docking of the command module and the lunar module. I have a clip on how docking is supposed to work according to the manufacturer of the command module, North American Rockwell.
And here at the home of Apollo, with Leo Krupp, who is the chief Apollo research pilot for North American Rockwell, it seems the question is, what does this mission mean in terms of the spacecraft, Leo? What are we asking it to do that it hasn't been asked to do before?
Well, Bill, for the first time, we're going to actually dock with the lunar module in space. So this will be the first test of our docking system. Also, after docking with the LEM while it's in the S-4B, we will eject it for the first time, checking out the spring ejector system. Following that, we're going to do several surface propulsion burns with the lunar module attached to the nose of the command service module.
And we've never done that before.
That's right. That'll be the first time for this. We've done it in a simulator many times, but this will be the first flight test. After that will be Rusty's spacewalk, of course, to prove that we can go from one vehicle to the other via the outside route. And following that, the LEM systems checkout and the high point of the entire mission, of course, which is the separation of the lunar module in a manned configuration for the first time, where they'll fly out about 100 miles, come back in and do a LEM-active rendezvous and a LEM-active docking with the command service module.
How complicated is this docking, Leo?
Well, the docking really isn't too complicated. It's a lot like in-flight refueling in airplanes. On the nose of the spacecraft, we have the drogue, which is extended about 10 inches, and the pilot flies in using a target on the lunar module and a sight in his window to mate the probe and the drogue. There are 3 capture latches in the head of the probe which engage the drogue and hold the 2 vehicle in what we call the soft docking configuration. The probe and drogue are mated. However, the 2 vehicles are still about 10 inches apart. As soon as Dave Scott has his attitude all aligned, he will then throw a switch in the cockpit which energizes a nitrogen bottle and retracts the probe and pulls the 2 docking rings smartly together. This releases 12 docking latches, and the 2 vehicles are then firmly mated in a hard docking configuration.
And those 12 latches, Walter, Leo assures me, are a good bet to go all at once. I asked him whether 11 out of 12 would be a reasonable guess. He said no, 12 for sure. Certainly we're counting on it.
I believe it is true that if they don't catch, the pilots can throw them manually, can't they, Leo?
That's right, Walter. We have an indicator in the cockpit which will tell us if we have 6 of them mated or not. And regardless of what the indicator tells us, Dave Scott will remove the tunnel, go up into the tunnel area and visually check each one of the latches. And if they're not mated automatically, he can mate them in a manual configuration.
At that altitude and that speed, they certainly better have a good catch to make sure everything goes.
What's the maximum speed tolerable there, Leo, for that docking?
Well, the limits, Walter, are from 0.1 to 1 foot per second at contact. However, in this particular docking that we're going to be doing today, the S4B will be 150,000 pounds heavier than normal since it has not done the translunar injection burn. So I'm sure Dave is going to go in very cautiously, and he'll probably dock at about 0.25 feet per second in order to keep the structural loads down, since both vehicles will be heavier than normal.
That's about equivalent of 1800ths of a mile per hour, I think.
That's pretty slow, but and once he gets contact, then he'll go ahead and thrust with his reaction control systems to push the probe into the drogue to make sure it doesn't bounce out.
That's
and he
so
can
slow.
hit within a foot of this funnel, and he'll go down into the hole and engage the capture latches.
That's so slow that I doubt that Bill Stout could hold his balance walking that slowly.
Now let's resume the mission of Apollo 9. After a little more than 2 orbits at T plus 2 hours 43 minutes, astronaut Dave Scott lit the pyrotechnics that separated the command and service modules from the S4B stage and the storage enclosure that housed the lunar module. Then he began one of the critical steps in the lunar orbit concept. He fired the thrusters and pulled the command ship away, turned the ship around, fired again, and drew near what he called the big fellow. Here's Walter Cronkite to fill in some details.
Reporting from the CBS News Apollo Headquarters, Kennedy Space Center, correspondent Walter Cronkite.
The launch and the first orbit and a half of Apollo 9 have been almost perfect, and the spaceship is now over Australia, approaching the east coast of Australia, and we've just been advised that already it has performed the first maneuver, a little bit ahead of schedule, apparently. It has already separated from the third stage of the rocket and has turned around and is facing back toward the third stage and the garage where the lunar module is parked, waiting docking, which is the next important maneuver, another 10 minutes away. What has happened is that the S4B, that is this large third stage, inside of it at the top is the lunar module. They have separated the command and service modules. They did that with a little 400 pounds of thrust from 4 of these 100-pound thrusters along the rim of the service module. And they just went away at, about 2/3 of a mile an hour. They drifted out 50 feet away. At that time, with their heads down about 10 degrees like this and yawed over some 15 degrees, now they have come up in a slow maneuver that took them about 45 seconds until their heads are now up and they are facing back toward the third stage. Now, in the meanwhile, we haven't had confirmation yet, waiting for it, these slaw panels, that is the spaceship lunar adapter panels, have blown away. This cover doesn't exactly represent it. It comes apart like a petal in 4 parts and blows away. We haven't had confirmation that has happened yet, but it will, and we hope to get that confirmation shortly. They'll station keep here about 10 to 15 minutes, 50 feet away. Now, this S4B engine may be venting a little fuel. That little bleed off may be coming out of the nozzles here in the back. If that is the case, it is accelerating a little bit. If that's the case, David Scott, the command module pilot who is flying this ship, will actually back up so that he keeps that relative position of 50 feet. Then when he gets ready to dock, he may let the S4B, if it is indeed accelerating, catch up with him. Or he may continue to back just enough so that their closing rate is 1/4 of a mile an hour, and you can hardly walk that slowly, until they finally get in here like this. And with a probe on the end of the command ship, he will fit that probe into a funnel-shaped drogue, it's called, on the nose of the lunar module. He has only 1 foot of tolerance, and he can't even see that position. He has to line it up with a little crossbar that is up here on the side of the lunar module with a reticle in the window of his command ship. Then he'll bring that in at that 1/4 mile an hour, very gently. It can't stand a great deal more than that. A very delicate thing this lunar module is, and he will dock with it. Then they will stay in that position for some time, testing the dynamics of the situation until finally springs are ejected here on a command from the command ship, and the whole thing is withdrawn from the S-4B third stage, which can then go on its way eventually into an orbit around the sun. That's the maneuver they're performing this afternoon at this point.
As Dave Scott pulled in closer to the lunar module, he noticed that the command module's nose was out of a line with the lander's nose. Scott tried to use a service module thruster to turn left, but that jet was not operating. It turns out that someone had accidentally bumped a switch that turned off one set of thrusters. The crew then flipped the correct switches, and the thruster started working. And at T plus 3 hours, 2 minutes, the command module probe nestled into the lunar module drogue, where it was captured and held by the latches. The first docking of the lunar module in space was achieved. As a side note, switch guards were installed on all future Apollo missions to prevent accidentally flipping a switch. Now here's a little bit more on the docking.
Houston, we've got you through the redstone, standing by. Go ahead. Roger, Houston, we're about 25 feet now on the closing point. Copy.
Said they're 25 feet away. That means they've closed half the distance of the 50 feet that they originally were scheduled to separate.
Apollo 9 is free to dock whenever the crew feels like they want to. They will not have to await a go from the ground. Flight plan schedule shows it about 3 hours over California, but the crew is free to dock when they desire to.
The crew apparently separated before they had their schedule called for them to by almost 5 minutes. The ground seemed to be quite surprised when they called up to apparently update data and to get set for the separation and the turnaround, and they were told that the spaceship already had separated and turned around. But now they're perhaps going to take a little more time with the docking. They have closed about half the distance, have another 25 feet to go. We're keeping an ear cocked here for further word. That is an excellent representation of the target that Scott is now aiming at. That black crossbar you see right in the middle of the representation of the LEM surface. He is getting that crossbar aligned with a position on a reticle etched into the glass of his docking window. And by keeping those lined up, he moves in and edges in. He cannot see the actual nose, the docking probe, or the drogue on the LEM. We just...
Apollo 9, this is Houston. I understand you got a master alarm just as you docked, and I didn't copy about the RCS. Right.
The transmission's a little garbled, but they did say we are docked at 3:02:08 into the mission. 2 minutes and 8 seconds after 3 hours. They also said they got a master alarm in their sensing equipment as they docked. They're reading that out now, and it may be meaningless. This shows the docking procedure that took place just a minute and a half ago as that probe went into the drogue and 3 small latches clamped it into a position just 10 inches away. It's called soft docking. Now they'll follow that nitrogen bottle that Leo told us about a little earlier. That will pull them together and seal them so that they can equalize the pressure between the 2 spacecraft, and then open up between the 2 of them, and later in the mission 2 of the astronauts, McDivitt and Schweikert, can crawl through that tunnel into the LEM.
Using our package tip on the Quad A is running about 200. What do you have down there? Stand by, Apollo 9. Let's check it.
What we did here just a moment ago is the angles looked just right of the docking, and the ground said it looks okay to us. There doesn't seem to be any concern about this master control problem. The docking seems to have gone well. Let's listen to a transmission from the Apollo 9.
The latches worked just right. There were no oscillations after we captured. We lined it up and did the retract, and it took about 10 seconds, and it sounded like we got a good solid lock. Roger, Apollo 9, copied all that real good.
They said,
Apollo 9, this is Houston. We'll have another state vector for you over Bermuda. Roger.
After docking, McDivitt and Schweikert began preparing for their eventual entry into the Lunar Module. First, they opened a valve to pressurize the tunnel between the 2 spacecraft, with Scott reading the checklist aloud. McDivitt and Schweikert removed the command module hatch and checked the 12 latches on the docking ring to verify the seal. Next, they connected the electrical umbilical lines that would provide command module power to the lander while the vehicles were docked. McDivitt checked the drogue carefully and found no large scars. Meanwhile, Schweikert glanced out the spacecraft window and failed to see the lunar module in the darkness, which scared him. "Oh my God!" he exclaimed. "I just looked out the window and the LEM wasn't there." Scott laughed and said it would be pretty hard to not have the LEM out there with Jim in the tunnel. McDivitt put the hatch back in place until time to transfer it to the lander. About an hour later, the astronauts activated the ejection mechanism, which kicked the docked spacecraft away from the S-4B. Apollo 9 backed away, and the Saturn third stage, after firing twice, headed for solar orbit. Thanks for listening to this archive episode of the Space Rocket History Podcast. If you are financially able, please support the podcast by going to the homepage, spacerockethistory.com, and clicking on the orange donate button or the Patreon link. Thanks.